Okay, so today's lecture will be all about how to build, how to test, deploy your React application, and at the end we'll cover a more advanced topic regarding the server-side rendering of your applications. Again, today's lecture is the same one as before, Dmitry, and a more in-depth agenda will be the following. We'll start by looking at the build. What is a build? Why do we need to build our applications? How we can build application using a boilerplate, such as create React app, or how we can do the same thing, basically what the Facebook team does with create React app, but manually control all the aspects using Webpack. Then we'll briefly discuss what is testing for React applications, what libraries you can use, what are the approaches for testing. Then we'll go a bit more into deployment, because it's not just you writing code and showing a local host results of your applications for your colleagues, but also you need to expose your applications, the end result of your applications to the world so that anyone can see it using the internet. So it's a very good and important topic, and we'll briefly go through all the options you have, at least the basic ones. And then, as I already mentioned, we'll cover the server-side rendering, what's the difference between server-side rendering and client-side rendering, what came first, what is the difference between them, and why do we actually need server-side rendering. Okay, and we'll start with build. In general, a software build is the process of converting source code files into something like standalone artifacts that we can sort of ship anywhere we want and run outside of our own computer somewhere on the server, for example. Basically, build is something that JavaScript essentially lacks, because all we need to do when we are working in the browser, when we're writing our application in the HTML, CSS, and JavaScript files, it sort of works, and it's not really a big deal, to the point that essentially we can do everything the old-fashioned way. And what I mean by this is that we can just include the file statically into our HTML and just live long and happy lives. But the production level applications are really, really huge. And they're written using some tools that transpile the code or maybe help you in some sort of way. So we can't just include script tags for all these files. So we need a process. And for something like JavaScript, this process is manually established by the development team. If we're talking about, for example, other languages like C, you can have a parallel comparison, because in C you actually compile your code. So building in JavaScript is sort of like compiling your code in more standard languages. By compiling a C language, C program, you end up with a machine code that you give your machine to run, sort of executive file. For JavaScript, we don't actually have this executive file, so that we cannot click on the file that we had just written. And so the browser does the whole thing for us. But sometimes we actually need some build process for JavaScript. And Webpack, the icon on the right, is actually the tool that helps us to build applications into some sort of static files so that the browser can consume them without worrying too much about the tools that are used underneath. And Webpack is generally a module bundler. The main purpose is to bundle JavaScript files, and it not just bundles all the files together, like smushing them and copy pasting code from lots of files across the repository and into one big, huge file. It also transforms the source code. For example, if you're writing the latest and greatest ES 2019 or 2020, all browsers like Internet Explorer, the infamous one, they don't really do well with those new and fancy stuff. So kind of not really um, able to run your code that is written in the modern way. So Webpack actually helps us with this problem. It can take your code, do some magic with it, and as the output, it will be the old-fashioned JavaScript like every browser can understand. And it does so without our um, actual manual configuration of how you should interpret const into bar, keyword, and so on and so forth. It also bundles your JavaScript file into a nice and compact thing that can be attached to the HTML. And essentially, by running Webpack transformation or build using Webpack, you end up with a ready-made file for deploy. And I think I covered lots of theory with this short paragraph, but let's go to actually some coding. And today's coding will be sort of like the previous day coding. So here I have the same testing app. I think I should have started the whole thing before I went to explaining. So we're doing the same thing in PX Create React App Test App. It's the sort of thing that you do all the time when you're starting a new project in React. And we'll see how this whole thing with building a project relates to Create React App. And what is the difference between actually using something like a Create React App, which is a boilerplate, and actually writing the whole Webpack configuration by yourself. And while we're waiting for the Create React app to be instantiated, we can go and explore some Webpack configurations that I already prepared for you. Here is a much bigger project. It's not really a Create React app project, as I remember. The project is written by one of your lecturers for React course, Victoria. And she wrote a very decent, and I should say not just decent, but nice configuration for Webpack, which follows lots of best practices. So when you have a Webpack configured in your repository, you will have something like webpack.config.js in the root folder, in the root path of your application. And as we can see here, this file is nothing more than a bunch of JavaScript objects. In this example, it's just a little process of deciding what object should we actually use, the development one or the production one. So as you can tell that by building some static files, you actually can build them in different ways. And what I mean by that is that, for example, when you're developing an application, you will have some kind of hot module reloading. So when you save a file, it automatically builds the saved file again, and you will see something on the screen. Or maybe you want to see all the names as they are in your files. You don't really want to have a small, concise build. You don't really need that. It's more of a production thing. So uh, the natural way of writing a Webpack configuration is to split those configurations into two different objects, as we can see here, depending on the node and development variable, environment variable. And a typical Webpack object looks something like this. So in the end, we'll have a single object exported out of this file, and the Webpack like module that we install using npm will actually recognize this Webpack config file. And since this Webpack config file exports one of the objects, either the dev or prod, this object in each of the files is the one that gets Webpack configured. So at the end of the day, your Webpack configuration would look something like this: a bunch of imports of the modules that you're going to be using, and the object with all the configurations. But this is how you write it from scratch, sort of say. So you have lots of rules that are defined here that will eventually lead to a bundle that for different environments. And the production environment is usually a more strict one with lots of rules disabled and obfuscation enabled and lots of nitty-gritty stuff. All this is available on the official website for Webpack. So if we go to webpack.org, you will find all the information regarding the Webpack configuration fields and how you are actually building the whole thing. And what I like about Webpack that became a really standard in the industry is that it can do lots of things at once without me writing the actual steps that it needs to be doing for all the different files. So as you can see, there is a little graph on the left that shows us all the files with the description of them, like PNG, JPEG, JS, and we just sort of pipe it into Webpack process, and output is those static assets that you usually deploy or usually build into a Create React app. So as I mentioned already, since we are going to look into Create React app repository, under the hood, Create React app is already using something like Webpack, or actually Webpack in general, and it does the whole bundling without you knowing it. So as you can see, we don't see any Webpack configuration here. But then how are we able to run the command? Since we are literally having lots of JavaScript files and lots of imports that are not really valid in the browser. So we cannot just write JavaScript with import statements and require statements and expect that the browser will understand this. So how are we actually able to write this code and without the Webpack configuration still able to see the result by running npm start? This is what the bootstrapping by the Facebook team is actually doing. It's that they hidden away the Webpack configuration that we expect to see so that we can literally have all the fancy stuff here. And they hidden away it inside the React scripts. So if we take a look at the package.json, we see that we actually running not just the node and the file that we need to run, we're running something like React scripts, and React scripts is one of the modules that we have in the modules folder, and it contains all those configurations that are actually happening in the background. So if we go to React scripts here, we see that this whole thing is actually bundling together the Babel, which is a transpiler for JavaScript code, .env, which is enabling us to have environment variables injected into our React application, ESLint, Jest for testing, and the Webpack itself. So how do we actually see that Webpack configuration happening? So if we close the build that is actually already running, and if we go and just disable the whole thing, and we run a special command that the Facebook team has given us. Could you wait a second? I have some urgent things to do. I'll be back in a minute. Okay, I'm back here with you. So as I was telling you that if we go and take a look at the package.json file, we have a really nice command, eject. And if we go deeper into the documentation for Create React App, it actually says that to see the Webpack and to configure the whole thing really in depth, we can run that command. And it actually what it's doing is it enables the Webpack to be seen, and yes, ESLint to be seen out of the box. And it actually says, are you sure you want to eject? Yes. We'll wait for a couple of seconds till it's done with the ejecting. But you might be wondering, why do we need this? In the end, why do we need all the configuration ejected? We can just use Create React App out of the box and not really worrying about the whole thing. In the production environment, the Create React App, which is a boilerplate, is not really enough to cover all the requirements of the production-ready application. And since the Webpack is something really nice in terms of configuration, we need to be able to configure all the dependencies, all the different modes that Webpack is exposing. So, as we've seen, the eject command has successfully run, and we're left with a bunch of new stuff that appeared in our repository. If we inspect the stage changes, we have a scripts folder and a config folder, and this folder is actually the ones that are used for build. So this is a build script, almost the same as the one that we've seen before, like this. And most importantly, we have all the configurations for our React application, which is a Jest, the testing configuration, the env, a very important one, and Webpack. So by the end of today's lecture, I want you to understand that the Create React app, as a really nice boilerplate, does the heavy lifting for you. And if you don't really need that nitty-gritty, detailed configuration of your build process, you can live with Create React App. But the thing is, if we go and see all the production projects currently using React library, it's really rare to find a Create React App started applications. It could be the case that they run the eject script and then tried to configure the whole process to fit the project requirements, but most of the time we are left with a manually enabled Webpack configuration. So what is a byproduct of like running the build with the Create React app, for example? So if we go and see the effect that the build command has, rub, nice npm rub build. We don't need rubbing a build, we need running a build. So there is this folder that appeared. So a nice thing to understand about the build product and the build process of any actually JavaScript application, be it a React application or Vue or Angular, is that we cannot just deploy the code that we are writing directly. We cannot just have this folder structure enabled. So we need some static files, and by the end of the day, all the frameworks and libraries, they end up using some kind of build process to have these files. So we just used Webpack configuration from the Create React app to have this build folder created for us. And what we see here is that we are left with all the same stuff that we're expecting, minified, and already ready for us to actually launch. So if I were to just use a file protocol or maybe a live server like this, I'll actually see something really disturbing. I have nothing on my screen, and in the console it says like lots of the files are missing. Because the Create React app expects you to configure the server for that thing to actually run, if I were to put it into the GitHub pages or something like Netlify or Heroku and do some back office magic there, it will run successfully. But the thing is, I want to see something on my computer using something like I don't know, live server. So what I can do to see the results and actually make sure that the whole thing is running correctly is that I just did the formatting, the auto formatting of this file, and I see that the paths to the paths to the files are not really correct with my current Windows machine. So be aware that this could be a still valid build product of your applications. But the thing is, the file paths are not really configured correctly for different environments. So in the Linux, we might have something like /. In Windows, it's okay to just leave it like that without the slash. And if I just go and randomly delete all the slashes in terms of the icons and go to my React applications, one thing left for me to do is configure the logo. But already you can see that using something like Live Server is already working. So I have all the sources downloaded. So if I go to the sources, I have the index.html with all the files that I need linked or imported into the thing. So this is the static folder, and the JS files are already there. And I can see that with the Webpack that comes from the Create React app, we actually have a source maps. I will dive into source maps later. But if we take a closer look to the end of the file, we see that we are bundling together not just the app.js file or some kind of index.js file. We have a strange definition here and here, and this is all that the Webpack does. These files are created by Webpack using our own files, and the Webpack bundled together all these files, and they look something like this, a really nasty looking thing that could be formatted using the DevTools, I think, yes, but it's all gibberish. in the end. Uh, but this gibberish is actually the least amount of symbols or variable names or function names that need to be there for your code to run. And since it's a least amount of names, if we go and actually look at the file sizes for the whole thing, it's not really much. It's 275 bytes of code. But if we had all the names, all the files, functions, and etc., and the old structure of the file disabled, you would see that the end file would be much larger. So, and if since I mentioned the source map, you can see when I hover over the name of this file, I have this little box that appeared the tip of my pointer that says index from the source map. So while Webpack it's bundling your JavaScript files into a like really concise thing that it's calling something crazy, it still understands stuff for the development environment for the developers. It's much easier to traverse not this minified code, but actually a source code, the same code that he sees in his Webpack, in his VS Code, for example, like this. If I were to actually inspect the static file for this to_chunk.js, I think this is the one that gets transpiled from the app.js that we are having in here. So I want to see something like this in my debugging tool. For that purpose, Webpack creates a special kind of file that helps debugging tools to show the initial structure of your file. A really nice thing to do. So as I mentioned already, for production level applications, for example, this one, we don't see any source maps enabled. If we go into the dev configuration for the whole thing, we might find the source map enabled. Yes, the dev tool source map. So if I were to build this application that Victoria written in the development environment, I would see something like this created: a bunch of chunk files that are minified and the original ones from the source maps. But if I were to run the production development, I don't see any source map configuration enabled here. So I would end up with the bare minimum of JavaScript files that are easy to transfer over the network. So it's this performance thing. So at the end of the day, a typical Webpack configuration would have you to write the entry file, as we can see here, the file that the Webpack uses as the first one to start bundling the whole application together. So what I mean by bundling, if we go to the index.js file of this application, we see a bunch of imports. And since we know that the imports are not very valid for browsers to pass and execute, we need to bundle it. And the Webpack does it using it, for example, the entry statement in the configuration object. Then the output file is the actual names of the file it will create and the place where it puts the files. So this build folder that I already ran the command for is creating a main.bundle.js, and as you can see, the main part comes from the variable or the placeholder name that we're using. So essentially, it will go look at the names of all the files, for example, app. It will find the app.js name and will insert it here. Bunch of really cool stuff comes from this intelligence of Webpack. The resolve is another field that we can configure. It will look into a specific folders. For example, if we need to point Webpack to our null modules and so that the Webpack can actually go get the node modules in the end build. It will do so by the result statement. Watch and the dev server are another very unique features of Webpack. If I were to run for example, different commands for the whole environment, I expect to see, for example, for start prod or start dev, that the Webpack is actually running in the web server mode and it watches my files, and it's not stopping the process. So if I were to run start dev, I expect that the process is initialized and then Webpack waits for the files to be changed. So we're waiting for the build, and the build is successful. So a bare bone verbose output of Webpack looks something like this. It goes and lists all the files that it transpiled or converted, and then it says the compile is successful. So if I go to any of the files, for example, the index.js file, the first file that it's actually bundles, start the bundling process. If I were to just do a slight change and save the file, we can see that the Webpack intelligently picks up those changes and rebuilds the configuration. But if we stop the process, essentially stopping the Webpack development server and stop the watch files, and if we just run the Webpack bare minimum, for example, build prod or build dev, it's not going to actually run anything in the console. It will stop running as any command that finished its task, for example, div build prod, and it will create the production folder for the whole thing, and I can take the folder and upload the whole thing somewhere that I want to deploy my applications. So it's essentially the same thing. It's minified the whole thing. Oh, little spoiler here. So in the end, Webpack is a tool that can be used to resolve a bunch of things, including CSS, HTML. It can do lots of stuff with the modules. For example, if we were to go to the module section of a typical Webpack configuration, we would see that it does something different for different files. So a typical rule for the module is test for a type of a file and then do some logic with it. You can also write a different configuration transformation logic for that. So you're not tied to default settings and default plugins that are already written for you. You can actually write it yourself. And as you can see, the resolve loader on the top level of the module Webpack object configuration, it has a different loaders that are customly built. So if we go to a typical loader in the source folder loaders, we can see that the whole thing is just a function, and it's the one that initially creates this spoiler or Easter egg in the HTML that it's not really present there. We can remove the comments. For example, as you can see that some of the comments are commented, some of the stuff is commented, and we can go and run some logic like a function that goes to the source and replaces everything that is commented, and we won't see those commented lines in the bundle in the end. So we can confirm it. Yes, there is this spoiler and no common lines. So Webpack enables you to run your custom logic with it. But that concludes the build process for my presentation. And we go to testing. I will just quickly check if we have any questions. No questions to the point. So testing. how can we test the application and what is testing in the end? So testing is a process first. Like a build process is one of the steps that we're typically doing in the production environment before we actually ship the newly updated application to the end users. So we build the application, we get those static files, and we try to test it, or vice versa. So this is just a step. And the steps enables us to ensure that the end quality of the product is good. For React testing, we have a bunch of libraries, and one of the first libraries that the developers of React library suggest is a React testing library. A more production-ready environment uses something like Mocha or Chai libraries. These are Mocha and Chai are the things that usually work together to deliver the testing environment and the test cases that we can write for our applications. And when the whole thing with Mocha and Chai are that they're so popular and the developers are using React testing library and the Mocha Chai libraries together. The Facebook team just noticed the whole trend with the usage of different libraries together and then came up with the Jest library. And Jest library is essentially Mocha plus Chai libraries with some additional tools from the React testing library that enables us to write a really nice tests. And as for the demo, I think another application that is written by Victoria is really helpful in this regard. So a typical testing environment that you set up for your React application usually starts with something like jest.config. So as I mentioned, we can go to the Mocha or Chai testing implementation, or we can just literally use the Jest by itself. They all will have some configuration file at the root level of your application. And this configuration file, just like we saw with the Webpack configuration file, is nothing more than an object. This is it, where we define all the necessary configuration for the Jest to run. So as we can see that we are using the node environment, we test, we're looking for the files that are in the source repository that end with test.js, and we do a whole bunch of other things. I won't cover testing in depth, but what I want you to understand that in testing we have Mocha.js, for example, and Chai.js. Yes. And if we combine Chai.js with Mocha.js and we do combine it with React testing library, we end up with Jest.io. Yes. So in the end, Mocha is just a test runner. So when we write the test cases, we need some way for those test cases to be run against certain files in a certain order, and the Mocha is used to organize the whole running the test process. Chai is a library that enables us to have assertions, as it says in the description of the library. Chai is assertion library. When we're testing for different things for React, or maybe for Angular or Vue or any JS application in general, even the Node.js, we need some kind of way to identify what we're testing. For example, we need to programmatically say if this is equal to that, then it's okay and the test passes. So assertion library is just a bunch of functions that are written for us. We use these functions to write the test case, and then using something like Mocha, we run a number of test cases. React testing library is also bundled with some utilities that are helpful when you're writing React testing, but Mocha and Chai, or even the Jest, which is a combination of the former, are used not just in React in general. So as you can see, yeah, they have listed things that are used under the hood or maybe used in different React, different JavaScript frameworks. So how does a typical, for example, Jest test configuration looks like? This is a configuration file, and if we go and look for the test files, so we go to RCC, tests. Okay, this is not the thing. Oops. For example, footer. Rewind a bit. I did some misclicking. Okay, so we're looking for the RCC folder for every test.js file, and if we have a look into footer test, this is a typical test in Jest library, and what it does, it just describes the several steps that need to be run in parallel or sequentially. So when I say that the Chai assertion library uses some kind of pre-made functions to assert things, this is what it looks like in Jest. So we assert that the component is to be matched with the snapshot, and this is a test case. If we want to have a bunch of test cases, for example, something like this, or if we can find maybe some other tests that are more verbose in this manner. No. So if we have a bunch of tests, we would have we need some kind of mechanism that runs those tests and one by one or in parallel, and the running part is handled with something like Mocha. And since Jest is built on top of Mocha and Chai, or at least the ideas behind that, just simply requiring some React enzyme and having a Jest config.js in our root level of our application is enough for us to not only assert things, but also use a describe an it or test keywords and run the testing. I'm not really sure if it's okay to try the code, but the thing is, I'm sure that the testing for this application is done really brilliantly. And when you test your code for React applications, what we typically do is, well, testing in general is like making sure that the function given some input is outputting the expected result. So what is a React component in general? This is an object. So the byproduct of a functional or class component in the end is just a bunch of objects. So we can use some pre-made functions like mount. We can pass the desired component, the React component, to that function, and we can expect that the result would be something like an object that we can test for some contents. And in this case, we're testing that the component that we just ran with the mount function is equal to a snapshot of a component. So really typical way that you test your components in the React ecosystem is that you first run some special command, or in Jest case, it's just the first test that is run on this component. We'll create a snapshot, and then when we save the snapshot, so let's go and see if we have some snapshot. Yeah, we have a component test snapshot. And when we save the component snapshot, we will see an internal structure of the snapshot. And if something changes in the component, we just mount the component again, and we expect that the change to the occur does not break anything compared to the snapshot. So this is called a snapshot testing for React, and this is the most typical way of testing in React application regarding the components. So I just wanted to try and run the test command if we have one. I don't see any test commands. Well, what if I just go like this? It's not. What if I just go like this without initializing anything? Yes, lens server. Yeah. So anyway, if we have a different kinds of testing, for example, for React application, this is a snapshot testing. For just a small function, we can have a typical unit testing, a unit test, which follows the same pattern that we see here. It expects some function to be run, and then we compare the results to the what we expect results to be, and we can have a end-to-end testing, or maybe I should say functional testing that have a bunch of unit tests run. If we go deeper into the testing thing, it's really easy to lose the track of time. But the thing is, and if we go deeper into the testing, there are a bunch of different tests that we can have: the unit tests versus integration tests, or versus functional tests. What is the point of this part of the lecture is that you understand that the standard tools for React testing, for writing any type of tests, are Jest library, Mocha, Chai, and maybe React testing library. With those libraries, with some configuration and deeper dive into their like internal usage, you can write any type of tests if the task is requiring you to do so. So we switch to deployment. I briefly mentioned deployment in the build section, and I just wanted to reiterate that the deployment is all those activities that we do when we ship the software that we want the end users to see. And if we take a look into one of the builds that we've already done, for example, the Create React App build, we end up with a build folder. And the deployment is the process for us to say, okay, I want this folder to be placed somewhere on the internet and be exposed in the correct way. So the same thing happens in the server. So I want to have the same thing to be happening for the remote version of my app as it happens locally. So don't mind the logo, but I want to be able to go into the URL and expect that the same thing that I'm seeing on my local machine to be available for any user that types that URL. So me transferring or uploading the data, which is my build folder, to some remote server, and doing some configuration of that remote server is actually the deployment process. As for my options, is like for React and the current Rolling Scopes school course, we have several options where we can deploy quite easily our applications in the end. And these options are GitHub Pages, the simplest one that serves a special kind of branch as a deployment point. Then we have a Netlify, a more complex way of deploying the same static things that we deploy with GitHub Pages and in a more concise way, I should say. Then we have something like Heroku, which is a deployment website, I should say, that not just used for the static files, or well, you actually can do this and use the Heroku application to have a static file served. But the main purpose is that giving the previous ones, GitHub Pages and the Netlify, you give them the static files and they just expose them. With Heroku, you actually go there to the application, the Heroku application, and you run a server. So you do something like logging to Heroku, going to the website that you want to launch, and you go and type npm start there, and it starts somewhere in the world, and it gives you a link to your website, and then you can share the link, and so the people will see the application as if it was running on your machine. The next level, a much more complex level for the deployment, is DigitalOcean. So the DigitalOcean is Heroku taken to like 10 times bigger scale. So we have a containers, like something like Docker, maybe Kubernetes, that is used under the hood for deployment in DigitalOcean. We manage those containers. We end up with the same thing basically, but a more professional way, I should say. So the application is resilient to the high loads of traffic. It has a bunch of professional or production level tools underneath. So when we are dealing with the client working or the production work, we're usually using something like DigitalOcean or their analogies. And in the end, if we want the full experience of doing all the hard work, we go and deploy our application to something like AWS, GCP, or Azure. So with these options, during the course, you're not expected to be able to deploy the simple React application that you're writing, the chat application, to something like AWS. What is sufficient is actually going to at least Heroku. If you are able to bundle the whole thing into static files without the need of a server, you can use a Netlify or even the GitHub Pages. I will dive a bit deeper into each one and show you how it looks in the end. So remember, for the current application, I have a build folder already made. So I expect if I push the whole thing to the browser in a special way to one of these options, they will run it for me. So what is GitHub Pages? If we Google the github.com and Pages, we'll have a really nice introduction into how the GitHub company expects us to build our application. It has a nice explanation for all the steps that you need to do, but in the end, it all boils down to you going to your application, just the GitHub page, for example, to, I don't know, what I can show you, the Arcane, for example. So as you can see, I have the same structure as we had with one of these apps. So really nice, structured into the folders, not really ready for the browser to run the files. But also I uploaded the build folder here. So in this build folder is already bundled version of the same application. And if I were to deploy the whole thing, it's already actually deployed to one of the GitHub Pages deployments. And as you can see, the environment it's using is GitHub Pages. And how can we know that the application on the just the repository, GitHub repository, is already deployed? We can check that the GitHub Pages will contain the bare bones build folder. So if we were to compare the build folder in the Create React app, for example, it's already following the same structure that we see in this branch. So in the end, what I did, I was in my master branch. I ran some commands like npm run build. I end up with this build folder. Then I copied the contents of the build folder into a specially named gh-pages branch and just uploaded the branch to the GitHub. And then automatically I went and enabled the automatic deployment of my application in the settings of the repo. So if we scroll down, to the GitHub section of any repository without even initial deployment, we see that all we need to do is just point the GitHub pages to the build folder, to the build static files, and the GitHub will do everything for you, and you will end up with some link that looks like this. So for really simple apps that are statically built, you can have a really nice deployment of your application. If I were to go to something like Netlify, the process is almost the same. So if I go there, I think I already logged in now. Yes, I'm logged in, and this is one of the websites that I was trying to deploy quickly before the lecture. And the process is almost the same. They have really nice UI for the build process. You can initialize the steps that needed to be done to build your product. So it's much more like complex, I should say, than just a simple GitHub Pages thing. But in the end, when you get used to the whole process, it's really simple. So if I were to go to the GitHub and enable the one of my accounts for the whole thing, for example, I can go to the same folder Arcane and say that deploy the GH Pages, and does not run, and you don't need to run any commands because it's already statically built. If I would just click the deployment, it will say in just a moment that the deployment is done already, yes. And I know already that the deployment is not really compatible with Netlify because I forgot to do some steps that they describe in, I think, the first page of the Netlify documentation. But it still see that the HTML is already here. It tries to build the React application, but it's failing to find the JS thing because of the slash there, almost the same that we had with the testing. So if I were to just re-upload the file and get rid of the slashes at the beginning of my JavaScript files, I would have been able to deploy it with the Netlify. But as you can see, the steps are really nice. And the Heroku is a bit more complex. You are not providing the build like artifacts to the Heroku. You actually start the server, so you upload your code there. And I logged out. So you upload the code there, You specify that to deploy your application, Heroku needs to run the npm start. You click deploy, and Heroku goes and does something like this. And when it's done deploying your application, instead of localhost 3000, you will get the actual link to your application, and it looks as if you were doing this locally. If we were to look to the DigitalOcean or AWS, GCP, or Azure, since they are much more complex in the production level, the steps to do the same thing to get the same results that I did in a few clicks are like much higher, and the number of things that you need to know is much higher. In the current course, you just need to understand how you can deploy your React applications to the GitHub pages or Netlify. So don't worry about that. And with that and the deployment strategy is complete, we are going to discuss the last section, which is server-side rendering. As far as I know, for your homework, you don't need to have a React server-side rendered application. But for your general understanding, I decided to include this topic into today's lecture. And we'll start with the definitions, for example. So the client-side rendered app is a recent kind of rendering method. So if I were to just go to one of my applications that is already running, it seems like I already have all the stuff that I need. So if I were to just reload, I see that the HTML is already there, which is kind of strange, because if I were to just go to the same HTML that I'm seeing there, public folder, I see that my HTML is kind of lacking the whole thing that I'm seeing. It has the div root and nothing else. So what is happening when I try to reach the localhost 3000? Where these files are coming from? And this is all about the client-side rendering. So if I were to put rendering word out of the technical details of how it's described in the computer science field, in the web, rendering is simply evaluating the necessary HTML and putting that HTML into a correct place of the HTML DOM. So I see that I have nothing in the HTML, but I also see that in the index.js file, I am inserting the whole React stuff, so the JavaScript byproduct of React application into the root. And if I was to go to the app.js and take a look at the div that it's inside, it's the same one that I see here. So the rendering that is happening is that I evaluate the whole React application, which is JavaScript in the end. I take that evaluated product and I insert it into some div element. And this is rendering. And what is client-side rendering? So the client-side rendering is that I expect clients, so my users that come to my site, to do this job of evaluating JavaScript, finding the correct place to insert the JavaScript, and do so. So what I mean by this is that I send them a whole bunch of files, and I bundle those files, I code those files in a way that it's obvious to their browser what to do with the files. So if we go and try to find the HTML file for this, okay, this is a server, so it's not really able to do so. But in the end, I go and I ship the index HTML file to them. I point that the JavaScript should be used in this HTML are these files, and the browser just takes the HTML, it evaluates the JavaScript, it does the job, and it displays for the clients the end product. So the whole rendering happens on your machine, on the client's machine. So every time any user comes to your website, it hits the link that you that you gave them, and they download all the build assets like this folder, and their browser, every time they hit your website, does the same job. Evaluate the JavaScript, insert it into the div. That was not really the case for the traditional web back in the days. Back in the days, the machine that was executing our JavaScript code, or the machine that was used by users to view web pages, was not really a powerful one. So those machines were just there to render and the HTML without any JavaScript capabilities. So what we did back in the days is that we were setting up the server that is exposed by the same link in the end, for example, localhost 3000. And when a user were to go to that link, we send the user not a bunch of files that their browser needs to evaluate. No, we build the whole thing before sending it. So we expect the user to just receive the HTML with some CSS files without any JavaScript, without anything. So by the end of the day, the server-side rendering is all about receiving the information in the HTML with already pre-rendered stuff. So a typical thing that would happen in the React application that is built with the server-side rendering in mind is that we will see a whole bunch of fields in the build artifact. So it's kind of like shifting a workload either to clients with client-side rendering or to the server, so server-side rendering. What it means is that clients do less work in the server-side rendering, and the server does all the heavy lifting of having to render the pages, and vice versa. If we want to have just a data server, for example, without static files sent to the user, we would go do something like this. So React began from the client-side rendering, but in the end, they decided that the use cases for React application from the client-side rendering perspective are limited. So they invented something like Next. And the Next.js, not this Next, but the JavaScript one. And the Next.js is a React framework that does mostly the same thing as we are doing in the typical client-side rendering React application, but on the server. So if we inspect a typical client-side rendering application, we will see a really familiar structure. So we have an index.js that inserts some stuff into a root folder, and all the files are written in a React fashion, a typical React functional components. But if we were to inspect the server-side rendered application, and I think I have it right here. Yeah, it's kind of the same. So we have some features, components. It's all just React application. So how does it differ from a client-side rendering application? It all boils down to how we do the configuration. So it expects us to have a server running that points to some kind of port like localhost 3000, some DNS mapping with the actual name like google.com. And when someone goes to that google.com, we are able to give them a already prepared application, as in JavaScript prepared application, and in a very easy way. So we have a typical server that listens to the localhost 3000. It lives somewhere on your servers, like Heroku, for example. The process is started. So on the server, we actually ran the npm run start, for example, like this. And it just stays there, infinitely like working. And every time a user comes to your server, we just go and serve some files to your user. We build those files and we serve them. So I think if I were to inspect the whole the Next.js application, it loads quite fast. So I expect them to do the same thing, to have a whole HTML is already built, yes. And if I go to my source, my HTML is just bare bones of that HTML. So if you compare my HTML is just a div without anything, but in the elements I see all this stuff. So this is a good like indicator that I'm using client-side rendering, and the Next.js.org, the like landing page for this framework, the Next.js framework, is using server-side rendering, and I know it because they have all the stuff already built into the HTML. If I were to scroll down, I see all the stuff that they're using. It's crazy that this application would have been written just using what they say, HTML, CSS, and JavaScript without any framework, maybe using jQuery. But the thing is, no, the React development tool has access to this website, and it says that it uses production build of React. So how am I seeing this stuff here? So, and this is an indicator that they're using server-side rendering for different purposes. So in the end, with the client-side rendering, we respond with a bunch of files, like HTML files. We download the JavaScript. We let the JavaScript execute. We'll let the browser execute the JavaScript files, like React files, and the page is already seen by the user. With the server-side rendering, we serve the statically built website. The browser receives the website in the already ready state, and it just shows the whole thing. We might be able to configure the server-side rendering in terms of we're still maybe using JavaScript in the end. But the thing is, the main difference between the client-side rendered app and the server-side rendered app is the amount of HTML already available to the client's browser. In the client-side rendering, it's just a bare bone div with the ID of root. And with the server-side rendering app, it's already built in the most of the functionality, and it's just running some additional JavaScript to have this kind of functionality available to the end user. And since I'm done with the demo, I think we've covered all the themes and all topics that I prepared for you today, and I'm ready to answer some questions. So Heroku is still quite difficult and can give a headache. Yes, because to use something like Heroku, you need to understand not just the front end side of web development, but the back end. So you need to understand that you have a Node.js running some server code serving your front-end application, and then you need the idea how you can build the whole thing, how you can provide Heroku with the commands that needs to run for you on their side. So it's kind of like more stuff to wrap your hand around. So I suggest you to start with Netlify or even GitHub Pages is much more convenient. And then with additional reading and maybe playing around with your applications, you can go and even conquer the AWS world. So do EPAM uses AWS, Azure, or GCP, or it depends on the project? To say it simply, everyone nowadays, every big or small company uses some kind of cloud. So AWS, Azure, and GCP are clouds. They may use some AWS, Azure, GCP clouds, or even they can build their own private cloud. So something like this. So EPAM uses all of them, all the options available, because EPAM is quite large. You told us about GitHub Pages, Heroku, etc. But what about Vercel? How does it compare to the static files? Like, Vercel is virtual. Yes. So if I were to put the Zate company, if we go to the next, I think it might have the same thing. Yes. So the Zate company, they develop a whole bunch of tools for front-end development, and one of the tools besides Next.js was Vercel, and Vercel in the end it stays somewhere between let's see, DigitalOcean and Heroku, I should say. They have a really nice way of abstracting away the complexities of Heroku and DigitalOcean, but under the hood, they use some container slash server logic that receives your files and does the heavy lifting for you. So it's okay, I think. But the thing is, with the tools that are doing lots of heavy lifting for you, you don't actually have lots of control on that. So in the end, the experience using something like Vercel or maybe the Vettel or maybe DigitalOcean is the same, is sort of like Netlify or GitHub Pages, but with less control than Heroku and DigitalOcean. Is it possible to have SSR and client server pages one app? If you dive deeper into SSR, you will find that a typical React application written with something like Next or server-side rendering in mind will do part of the work on the server. So we will prepare the pages, the basic structure, the pages, but it also will populate some state and give you, the user of the website, the state. The user will use a client-side rendering to have all the HTML already ready for consuming, visible on the screen, but also will take some state that you provided with SSR logic, and it will do something called hydration of your application. So you can understand it. You can sort of like build a mind map about the SSR typical use case. Is that you build the 90% of your application on the server, then you give all the rest to the client, and the client will take that 90% of the work and it will have like 10% done on the client side, so that it's not just static files in the end, but the really dynamic one. So yeah, interesting. Thank you. You're welcome. So if you want to dive deeper into the SSR use cases, try Googling for hydration, the React hydration. So it's like there is a method in the React library called react.hydrate. And the hydrate method is almost the same like render. We use a render method in class components to render some JavaScript, JSX to the browser. But when we have already built HTML DOM in the browser, but we want to have React attached to that DOM and listen to the DOM changes as it does automatically by default in the client-side rendering, we want to rehydrate the DOM, meaning we analyze the already made for us DOM tree, and we enable React to listen to the changes on the nodes. And then from that point, when you run hydrate method, you are just doing a typical client-side rendering in React. That's it. So the steps are render something on the server using server-side solutions for React, send those files to your clients, and on the client side, with those 10% of JavaScript logic, do the rehydration of your DOM. And from that point, you're doing a typical React. That's it. Okay, so any other questions? This lecture was actually intended for you to have an overview of the JavaScript ecosystem and the practices that we're having in the typical day-to-day life of front-end development developers and the ones that are actually writing React applications. So it's not really a necessary knowledge or like must-know thing to finish the React course, but for your later development as professionals, it will be much more easier for you to understand the broad view of the ecosystem and the practices that are used in front-end development. Brilliant lecture. Thank you for your time. Thank you for your time also. Well, how we will be unit testing are we at? If I were to write some unit tests for React application, I would just go to YouTube, type React Jest, and find some really nice lectures, and they will cover mostly the stuff that is needed into typical testing practice on any project. It will fall into, like, I think, two categories. Either you test functions that you write, or you test your components. And the components testing is just some kind of rendering the component and testing if the rendered version is the same as the one that we already saved. Thanks for clarifying the topic. Okay, so if you don't have any other questions, I think we're done with the lecture, and I hope you liked it, and I or Victoria will see you in the next lecture. Thanks. Bye.